Welcome. Hello, everyone, and thank you for being here, taking the time to listen to me. My name is Mr. Nedjemeddine derdar, MCA of Higher Normal School of Technological Education, Skigda. Before beginning the representation of my work titled Existence, Uniqueness, and Continuous Dependence Results for Nine-Liner Hybrid Implicit Fractional Differential Equation Involving a Capoto-Fabrizio Derivative. Up to now, there have been defined some fractional derivations, of which most used are the Capoto and Riemann-Liouville operators. The applications of the fractional calculus with these two main derivatives can be observed within a huge range of real-world phenomena. In order to increase the power and applicability of the fractional calculus, some researchers suggested a new type of fractional derivatives possessing different kernels. Thus, Capoto and Fabrizio defined recently a new fractional derivative possessing a singular kernel, and the properties of it were discussed in reference 1, 2, 3, and 5. The Capoto-Fabrizio fractional derivative CFFD has added a new dimension in the study of fractional differential equations. The beauty of this new derivative is that it has a non-singular kernel. The interest of this new approach is also due to the necessity of using a model describing the electromagnetic systems, the algorithm model, different scenarios in fractional dynamics, fluid flow in a reservoir, transition to turbulent flows, cancer cells populations with fractional derivative under radiotherapy, behavior for immune and tumor cells in immunogenic tumor, thermal media, behavior of classical viscoelastic materials, and it can be used for modeling of processes with various types of memory effects, etc. In this work, we are interested in the existence, uniqueness, and continuous dependence of the solution on various data for a nine-liner implicit Capoto-Fabrizio fractional hybrid differential equation 1, 2. In this section, preliminaries, we introduce some notations and definitions of Capoto-Fabrizio type fractional calculus and proposition concerning the form of the solution of problem 1 and 2. Our first result is based on Banach fixed point theorem. We assume the following conditions: H1, H2, H3, and H4 to prove the existence and uniqueness of a solution of problem 1 and 2. To transform the problem 1 and 2 into a fixed point problem, let us consider the operator P defined by the formula 6. This shows that P is a contraction mapping in space C, J, R. As a consequence of theorem 1, there is a unique fixed point X CGR such that Px is equals x, which means that the problem 1 and 2 have a unique solution on J. Our next result is the influence of a perturbation of initial data to the solution of problem 1 and 2. Assume that hypothesis H1, H4 hold, and let X and Y be two solutions of the equation 1 by simple calculations, and if RHO 1 1, then from which we get the inequality 8. By theorem 2, we observe that the solution X of problem 1 and 2 depends continuously on the initial condition. Finally, an example is given to illustrate the result.